Hey everyone, this is Michael from the Data Incubator. We're really excited to have you. This is another installment of our regular series, Data Science in 30 Minutes, where we do we invite a guest on and do a little bit of, data science and talk about that within 30 minutes. So I'll say a little bit about myself. So I'm the founder of the Data Incubator. We are probably best known for running a fellowship for PhDs and master students looking to enter industry as a data scientist. It's completely free for the fellows to get in. And if you're interested, you can learn more and apply at thedataincubator.com. We also do a number of online courses. If you can't commit to sort of spending a full 8 weeks doing a fellowship with us, or maybe you don't meet the qualifications for the fellowship, we do online courses that sort of are more introductory and are geared towards working professionals. And you can see our online courses on machine learning, TensorFlow, and the foundations of data science, also at thedataincubator.com. So today we're here for another installment of our regular series, Data Science in 30 Minutes. This is a regular series that we do. It's a monthly series, and it's about the role of data and AI in the world. Just to give you a sense, past speakers have included Becky Tucker, who was a data scientist at Netflix, Jess Strauss, the VP of Data at Quantopian, Holden Karau, who's an engineer at IBM, now Google, and is a core contributor at Apache Spark. Andreas Mueller, who's one of the creators of Scikit-learn, and Sam Swift, who is a VP of Data at Betterment, and also a former fellow at the Data Incubator. And before I introduce today's speaker, I wanted to remind everyone that you can pose questions in the YouTube chat area. So right below where you're watching us, there's a little chat area, and you can start proposing questions there. We'll monitor it, and we'll take those questions and ask our speaker those, or I can answer them if I'm qualified. But you do need to be logged into your Google account in order to ask those questions. So make sure you log in if you have any questions to ask. So today I'm talking with William. He leads business and corporate development, partner initiatives, and strategy at datascience.com. And he's their chief strategy officer. He most recently served as SVP for strategic alliances and GM of dynamic pricing at MarketShare, where he oversaw global business development and partner relationships. And he successfully led the company to a $450 million acquisition. So, and speaking of acquisitions, I'll turn it over to William, who will maybe relay some exciting news.
Thanks, Michael. Thanks for having us on today. Sounds like a great session that you guys do here, and we're happy to participate. As Michael said, my name's William Rashan. I lead strategy for datascience.com. We did have some news yesterday that we're working through a acquisition by Oracle, and we're excited about that opportunity, and we think they're a great fit for the business and think it's a really exciting next chapter for the company, and to work through scaling data science and enabling it for large enterprises together.
Wonderful. So I think, William, you have a worksheet that you sent out to participants. Maybe go through the worksheet a little bit and explain about sort of your sense of data science within the enterprise, and some of the ways that large companies, especially legacy non-digital first companies, can use that and to kind of assess themselves to see where they stand.
Yeah, that's right. I think we shared it with some of the folks that are on today, and if you don't have it, I'm sure we can follow up and get you a copy of it. But what datascience.com does is we're a data science platform provider, and what that kind of puts us in the ecosystem is sort of a unique position where we talk to large companies that typically have built out a fairly sophisticated large data science team, and when we get the call or they reach out to us, usually they're at the point where they're trying to figure out, how do we organize these teams? How do we scale how we work together? How do we build this out in a sustainable way? And how do we start measuring results of our data science outputs? So in talking to all of these teams at large enterprises, a lot of times what we get asked is, well, how are we doing? You talk to other companies, how do we stack up relative to them? And, do you think we're performing well or not? So through those discussions and all these meetings that we've had with different companies and feedback from the community, we built this, what we call a roadmap worksheet. And the intent of this roadmap worksheet is to give some of these large enterprises a sense for what is their starting point and what's the opportunity for growth. So we like to think of all of these things as guidelines. There's always intricacies and sort of specific requirements that some of these companies might have based on their industry or maturity of data science or how their team's organized. But we've really boiled it down to 3 broad areas that we've seen are the difference makers. So one being talent, and it's no mistake that that's the first one, because without a team and a high quality team, there really isn't a conversation to have around data science productivity or how to improve it. There's a lot of hype around automation and machines replacing humans, and what we've seen is that that's still far off in many of these companies. A human is not just in the loop, they are driving the definition of the loop and building it. So talent's usually the first one. The second one that we see is technology, sort of where they're at in terms of adopting some of the latest tools and packages and libraries that are out there, and then putting those things into work. So how are they actually applying the technology with their team to drive impact? And we call that broadly techniques. So what are they doing to move the development of data science work to a place where the business unit and their stakeholders can start getting value out of it? So those are the 3 broad areas that we've looked at that really separate leaders from laggards in the space. And we've developed this worksheet to help drive that discussion at these organizations so they could set up goals and build out a roadmap for their team.
Yeah, and if we look at your taxonomy, you're breaking it up between talent, technology, and technique. Obviously we're very interested in the talent side of things. We'd love to sort of dive deeper into that.
Yeah.
Tell us a little bit about what you think are some of the big drivers for talent in terms of this roadmap or maturity model.
Yeah, I think what we've seen is that this really is one of the fundamental difference makers, and companies like Data Incubator, I think, can play a key role in that, sort of driving the initial onboarding of new talent. So how do you vet new talent to make sure that they're successful when they come on board within an organization? And going through a program like yours is certainly a high bar and sets a standard. And there's sort of a—
Thank you for that.
Yeah, we've seen it in action, so it's great to see. So I think that's sort of the starting point for a lot of these teams is, how do I make sure I have the right filter up front to bring people in that are going to be high performing once they come over? And what we've seen is that a lot of times it comes down to both that initial hiring process, but also retention being a key metric. So when we looked across all the companies that we work with, some of the benchmarks that we've seen are, if you're hiring new data scientists, one way to vet are we doing well or not is how many are actually accepting job offers. So that's really one of the final metrics you can judge HR productivity or kind of talent productivity around is, when we make an offer, are we actually getting these high quality data scientists on board to work for the company? So, are you making it an attractive workspace for them to do continued development, work with peers? Are you publishing outputs and, building thought leadership in the community? And that's really what a lot of data scientists want to see. It's great that they get to actually apply the techniques that they've learned in academia and post-academia, but if you're not giving them the opportunity to grow, to work with peers, and to give back to the community, you're probably going to fall short. And that's where you'll lose to some of the tech or digital natives, like you said. You know, it's hard to compete with Google, Facebook, and Tesla for a data scientist. So what can you do to stand out and differentiate? So that's usually one of the upfront metrics that we look at. The second one is around churn. So, you know, as data scientists come on, what is their tenure? You know, how are they actually growing? Is there a clear path towards development and management versus someone coming in and just being a data scientist for the next 10 years? And you know, if you don't have those established, if you don't have a clear development plan, what we've seen is that it's not uncommon that the average tenure is less than 12 months. So people will come in, learn some basic skills, learn some techniques, and then they'll go move on to the next company that might be a little bit sexier, doing some work that's applicable to whatever they develop for your organization. So those are really the two key KPIs that we've seen. And, you know, some of the thresholds we've seen are, you know, you want to look at, you know, can we get, for every offer we make, are we getting over a 70% acceptance rate? And then for churn, can you keep it below 30%? And that's a pretty ambitious number given the average tenure of data scientists. But, you know, if you think of 1 year being at least the minimum bar, can you keep it below 30%? And if you can get better than that, or if there's a better benchmark for your organization, you know, those can always be adjusted as well.
Yeah, I think that makes a lot of sense. You know, one of the things, since we work with a lot of hiring companies, some that are sort of like yourselves or ourselves, digital natives, and some that are established enterprises, right, that have been around for sometimes centuries.
Yeah.
I think you have to, one of the things that the more established legacy players are always worried about is how can I compete with a sexy company like a Google or an Uber? And I think that there's, you know, one thing that is perhaps in their favor that they often don't realize is that a lot of times the kind of problems that you're solving, if you're an established healthcare player and you're trying to help cure patients of diseases or help shorten their hospital stays, or you're a bank and you're trying to make sure your products can actually serve the underbanked and unbanked, yep. That's a really compelling mission. That's perhaps more compelling even than, hey, I'm going to help a bunch of affluent San Franciscans like do their laundry for a little less and more automated way, or like, yeah, let's target ads a little better, right? Which are like, all those things are great, but I think that you know, that sometimes there's a lot of sex appeal in a legacy enterprise that they are often actually just not good at articulating and marketing, and it's almost sort of like a lost resource.
No, I think you're spot on, and I think there is that opportunity for companies that are established, have a long history, and, you know, have had success in their industry to apply data science techniques to show clear, measurable value. And I think for the data scientists that we've worked with, they get really excited about that too. Like you said, I mean, if you can come in, apply some of these techniques in a already successful industry and show impact, that's a massive opportunity for these organizations, which is why there's so much investment going into the category, and that they see that. I think the disconnect that we often see is that, you know, going from R&D and development into their product morphing or changing into call it a data-driven product, or one that's informed by data science, that's often the missing link. And how do you bridge that gap? So I think that's where a lot of attention is sort of shifting to now, is like, how do we actually make sure this huge investment in data science development is actually seeing the light of day so we can start seeing the impacts?
Okay, yeah, and I think, so one question we have from the audience is about exactly that. So if we have this disconnect, I would sort of almost phrase it, if, you know, within a traditional corporate context, I think this question would be phrased as, look, this data science stuff is great, but you guys are just a skunk works. Right. This is all research, pie in the sky, you might as well be an ivory tower.
Right.
how do you sort of bring about that and translate that into actual action at the enterprise? And I think that's not really a technical question. It's a organizational, sociological question, right?
Yeah, I think it probably takes both. I think, in some cases, some of these organizations are behind on the technology curve, where they might not be doing things that are what we, in our industry, and what we do is sort of viewed as the basics. Like, hey, we're, checking in code in a consistent way. There's version control. There's a clear model development lifecycle. We understand how we take a model from development to QA to testing to go live to reviewing the outputs of that model for refinement over time. So I think that whole workflow needs to be established and agreed upon up front with all the stakeholders. And this is where like you said, the sort of behavioral or organizational side of this comes in, is that you need to have alignment from the business teams and the broader organization on how are we measuring success? And then what is an outcome that can actually be applied to the business? And if those conversations don't happen at the beginning of data science development, you're almost by definition going to get to an answer that is going to go on the shelf and just be viewed as an R&D skunkworks project. So I'd say that that's something that we've definitely seen as being a differentiator between some of these organizations, where, if they're viewing data science as a back office function or an R&D team or a purely research team, they're completely missing the point. I think the higher performing teams are the ones that are embedding data scientists into their product groups, into their business teams, that are defining, what is the product we're launching and how do we actually get it into customers' hands, whether it be a enterprise or a B2B, B2C customer. There needs to be that alignment. And if there's not, if they're just viewing it as a research project, they're not going to get the value that they want out of data science.
Yeah, and I think that's one of the places where we've seen time and again, some companies have succeeded and some haven't, right? And the ones that have succeeded, it's sort of not only this like organizational mindset of, hey, this needs to be embedded in the specific business divisions and lines or product divisions and lines, but even like the data science teams themselves will start working with the business stakeholders from day one. So It's not just hey, we're going to solve this problem and hand you a magical solution. Ta-da. Right. Hey, look, what are your problems? What are your pain points? Okay, if I did this for you, if I could move this number up for you, does that help you? Okay, here's some analysis that might show you why you should believe that I can move this number up if we pull this lever, right? And it's a very much starting from the end conclusion, what you want to get at, what KPI you want to increase first, and then moving upstream to, okay, well, this is how you do that, this is how you measure it, and finally here's the lever, pull this one.
Yeah, and I think you're spot on. And I think one of the things that we probably highlighted in the worksheet is this idea of not only doing that definition up front, but once you're actually in development, being very agile in how you're doing your development process, because I think there's a tendency, and it's not across the board, but there is a tendency, I would say, with people that come from purely a quant background or a research background to, take that feedback and go dark for a very long period of time before they start doing their development. And what we've seen is that the most successful teams have a very quick feedback loop where they're communicating with the business team, they're communicating with engineering, they're presenting, what are the initial research findings? What are the options in terms of tackling the challenge that's been put in front of the data science team? How does that actually translate into a model that might be selected over time? How does it translate into an engineering requirement at the very end of the cycle in terms of building that feature into a product? And those quick, agile feedback loops we think are definitely a best practice, because it's making sure that all those stakeholders that are involved are clear on how we get from problem statement to, whether it's a mobile app or a website or some product, there's an interaction there where a human's touching it or a machine's touching it, and everyone's clear on how you're judging success. And you know when to go in and intersect and make changes, but also you know how to measure value. And I think having that full cycle defined and being very open in the communication process and collaborating with those teams is definitely important to keep in mind from the beginning, but also all the way through to the process to where you're live and in production with your models.
Yeah, I mean, I think the mantra there is really perfection is the enemy of progress. So I think especially, I don't know, this is maybe particularly severe amongst PhD data scientists, where there's this like, well, you know, I had 5 years to work on my thesis and it was perfect. So let me spend 5 years working on this problem you gave me and it'll be perfect too. And that just like doesn't work, right? You do have to sort of, you know, you show the ugly results and the somewhat good ones, and then right. That iterative process is very important in making sure you get buy-in and adoption.
Yeah, yeah, it's funny because I think one of the things that gets lost in this conversation between engineering, business stakeholders, and PhD data scientists, but any data scientists, is that the goal in many cases is not model accuracy or model perfection or data perfection. It's actually business results. And like, there may be a model out there that is far inferior in terms of accuracy, but delivering much more value to the organization that might be the one that ends up getting used. And I think people need to be okay with that. And that's really the goal of it. It's not how perfect can you get your MAPE or your R squared on a model. It's like, let's get to the point where we can actually start using it, getting value on it, and then iterating from there. If it gets perfect over time, that's great. But it's really about shortening that cycle from development to impacting results.
Yeah, I completely agree. So one of the other sections you have here is education and learning.
Yep.
So obviously data science is a constantly evolving, constantly advancing field. What are some of the best practices you've seen for how organizations can stay on top of new trends, new technologies?
Yeah, and I think this is one of the areas that's really challenging, for any team, because it's constantly evolving. The space. Every day there's a new package released or a new version of a library that's being pushed out or some new innovation that looks great. But how do you stay on top of those things? And I think all of this is related, right? So I think what we've seen is that the teams that do this very well have a program in place, and it's a very clear, repeatable process for them to go out and do things like training sessions, focused training sessions on applying new techniques, trying new technologies, getting their arms around what is the latest in the industry and how do we apply that to our business. So the best practice that we've seen is that they have a program. Some companies have nothing, where it's like, hey, just bootstrap it and you figure it out, which we don't think is a best practice. It's more about, how do you get feedback from the data science teams on what are they interested in? Do they want to start applying, deep learning techniques to a use case internally? If they do, go find an expert, bring them in for a workshop, have a focused hands-on training session where they can learn the skills, they can learn how to use it, and then start applying it, and do it on a regular basis. This isn't something that you could do once and say, hey, we've figured all of this out, we don't need to do training again for another year. I think keeping it ongoing cycle around this is critical. The other one is ongoing education, because this isn't a static space. It's one that there's constant innovation with the use of open source and the community continuing to develop around these open source technologies. There's no way you can stay current if you're not continuing your education and growth. So we also see that a lot of the higher performing organizations will send their data scientists out in the market. So go out, go to seminars, go to training sessions, go to conferences, and learn what's the latest and greatest, and learn from the innovators, the digital natives, like you said. And we think that's definitely a best practice. So, not sitting back and just saying, hey, we're gonna, once a quarter is enough, we're just gonna do this training program, but getting them out there to consume the latest and greatest at, more advanced conferences and seminars where they can pick up new techniques and bring them in-house to apply to various use cases that might be there.
Absolutely. Just you mentioned conferences. I think that's one of the places we've done a lot of trainings. We've done basically one or two trainings at every single strata going back for a year and every single strata coming up, and they're always sold out.
Right.
And I get the sense that like a lot of the participants are just super hungry for, hey, I need to learn more about TensorFlow or practical machine learning, or even just simple data wrangling, right? The nuts and bolts of it. So we have a question from the internet. What areas of education and training should companies focus on for building data science capabilities at scale?
Yeah, and that the answer to that I think does vary based on maturity and the size of the organization and industry. So it's hard to give a blanket statement there, but I'll say maybe generally that usually what we see is that there's, different types of data science teams, ones that might be long-standing, that are large, that are maybe very comfortable in the techniques that they've been using and applying for a long time, that, there could be a very disruptive approach that they just haven't adopted because there's, at some point there becomes this internal inertia around development processes and how they're doing their job where it becomes hard to change. So I'd say in those ones, I think it's a lot about how do you help that team re-equip or retrain in this new world of open source data science development. So these might be teams that are great at doing, C programming, or doing, kind of core Java programming, or different, programming languages that have been long living, but they haven't touched Python. They've maybe attempted to use R, but they're not quite comfortable to the point where they could say, hey, we want to develop in these environments. And I think for them, a lot of the training is around the basics around learning these new languages. These are all, proficient, highly capable people, but they haven't learned some of these new techniques. So for them, I think it's about re-equipping the workforce. And usually the best practice there is building that out from a center of excellence. So finding a small team that are maybe somewhat proficient and using them to train the rest of the organization. That's probably the best technique there.
We've seen a lot of the sort of center of excellence company or organizations, let's say, within enterprises, and I think that they actually often are also sort of people who are spearheading trainings because they're the ones who see the value of even simple things like using version control, or maybe more sophisticated things like using machine learning and deep learning. But they're sort of the tip of the spear, if you will, in this broader analytics effort. And so they're kind of pulling the rest of the organization along, saying like, hey, we should really be more data literate about these things,
right.
And sort of effectively becoming the sponsors for trainings. And I think what we've often find is that they prefer to do more of a mentoring role almost, as opposed to a training role, because for them, the best use of their time is not to teach someone how to use scikit-learn, let's say, which is something that we can do. They have a specific domain knowledge for their own code base, of their own domain and problem. So they're often like the people who mentor other researchers about like, okay, so now you have scikit-learn, but these are some of the tricks and nuances of our data sets. These are some of the implications because of different regulatory constraints that we have. So that some things some regressions you may want to run, you just can't, right? And so that kind of knowledge is really important within these organizations, and that's oftentimes what the Data Science Center of Excellence is doing.
Yep, absolutely. Yeah, and maybe just to answer the question another way too, is that one of the big gaps, and we touched on it earlier, that we see is really more of a organizational alignment gap or a communication gap. So I think one of the things that we've seen is that getting either engineering and data scientists or the business team and data scientists together for joint training programs around things like agile development, around product development, best practices, that's a very helpful thing to do. So it's not so much about specific skills for data science development, but it's more about how are you communicating? How are you doing your development process? Getting alignment with those other organizations that the data science team works with. I'd say that's also another big area of growth in terms of training that we've seen. You know, when companies do that, there's a very meaningful improvement in terms of performance typically.
And do you see that as getting the data scientists to be better, let's say, engineers, or getting the engineers to be better data scientists?
Yeah, and I don't think it's so much around like, you know, one becoming the other, but more about alignment between the two. Sort of, you know, I think the expectations between the two in terms of, you know, what is a finished model, what is a production ready model, what is a, you know, the application of the development that a data scientist have done into the engineering environment, and having clarity around those handoffs. I think that's the area that there's an opportunity. There's certainly cases where one side or the other picks up skills and techniques that the other might have, but I do think there's also a need for specialization, especially when you get to the scale that some of these organizations are. It just doesn't make sense to have people fully trained in both areas. You need to have some separation of expertise.
Yeah, no, absolutely. And I know one of the areas that you guys actually kind of excel at is model management.
Yeah.
And I know this is kind of a, you know, this is an increasing pain point, I think, amongst that lies somewhere between engineering and data science, right? It's you guys keep on churning out these models. We don't really know, like, do we put them in source control and call them code? Do we? It's kind of like code. Do we, like, what do we do? So how do you guys solve that problem? How do you think about that problem?
Yeah, and I think it all comes down to the big friction point between these teams, which comes somewhere around the point where a data scientist has finished their development process and says, "This is now done. Engineering, here, take this and move it into production." And I think there's a pretty broad spectrum of how that gets done in organizations today. The ones that we've seen are higher performing are ones that, you know, there's not a big burden on IT or engineering to take that output and deploy it. The data scientists can be self-sufficient. The role of the IT and engineering team in that scenario is more around, once it's moved into production, can it be QA'd? Can it be tested? Can we compare multiple models that are in production? And is there a feedback loop in place to say, hey, is this model still performing as expected? So I'd say if someone has like achieved the nirvana point, they're to the point where data scientists can manage that full workflow fairly independently, obviously with safeguards around things like data privacy and security and all the usual things that need to happen, but they can take it all the way through. What we've seen for teams that are kind of lagging or not performing at par is that there's really no capability there. So, you know, there's this sort of hard stop where a data scientist says, I'm done, development complete, and then engineering comes back in, you know, a week later, 2 weeks later, depending on what their release cycle is, recodes the entire thing in whatever their preferred language is, and then attempts to move that into production with, you know, very questionable results in many cases. So,
the thing about training models, right, machine learning, is that it's so finicky based on the little assumptions you make.
Right.
And you take the model and you train it, and you just, like, you know, miss one little transformation in that data pipeline, and the model is just spitting out gobbledygook.
Right.
And it's sort of, you know, I think like the sort of QA around that, I guess, is really important. And I don't know if people have, have really kind of developed systems in place like we have with software, with unit tests and integration tests, and, you know,
I think that whole cycle, I think, is still an area for improvement for almost every organization. I think one of the things that we usually see too is that there's so many other downstream effects of deploying a model. Like, what does it do to performance? Is it slowing things down in the data pipeline? Is it, you know, creating issues in terms of a existing workflow that's already there? So I think there's lots of considerations that usually aren't even thought about when someone says, hey, we need to build a new model for fill in the blank. But I think part of the idea is how do you open up that communication process so that people are thinking about that up front versus trying to hack it together at the end of the line, which is not an ideal situation for the data scientists or the engineering team in that scenario.
Yeah, absolutely, absolutely. So we have some interest in deep learning and kind of, I guess, GPUs and that side of the house. I don't know if you have a lot of support for that within the actual datascience.com products. Do you have, where do you see that going for the industry?
Yeah, and I think it's certainly in both of those areas, it's still very early days from what we've seen. I think the use of GPUs and the interest is very high, but I think it's very narrow today. In most, I'd say every time we get asked up front from any customer we're talking to is, what's your support for GPUs? How do you work with GPUs? What's your approach or strategy to GPUs? And then as we deploy it, we're like, great, where are the GPUs? It's sort of like, oh, wait, we don't have any yet. We might be interested in accessing some via a cloud provider, but they're not actually in production yet. So I think there's a little bit of mismatch in terms of hype and realities in most organizations where, if they do have them deployed, they might be kind of very purposely used for a data pipeline or some recurring cycle in terms of data processing, but they may not be used for actual data science development. In terms of deep learning, I think there's equivalent, if not more, interest that we're seeing across the board in that. But again, I think there's also very specific use cases for it today, hopefully more develop over time. And I think as more people start to adopt it, I think we'll see more use cases in various industries open up. But I think the reality is the application of deep learning techniques is fairly limited today. If you think about the entire ecosystem or kind of various use cases for data science development. So we see it being used, but I would say that it's not, if you were to say like, what are the most used techniques in data science? It's very low on the list today. Lots of interest, currently fairly limited usage for very specific use cases like image classification or text analysis. But if you think about the body of work that a data science team might be doing, today it's still fairly limited in terms of adoption from what we've seen.
Yeah. I think that's still very true. And it is amazing how much I guess enterprise clients love to talk about all the things that they don't have and ask you to build support for them. And then when you sort of show up, they're like, "Oh, no, that was just a question on a lark." I saw a seminar on TensorFlow, and now I think every vendor needs to support it.
Right. But I mean, in the end, it's like, okay, how are you doing time series analysis? Let's start there, because the true reality is that's probably what the team is doing most of the time, and then
exactly,
go from there and build up, right? So.
It's always the boring stuff that no one wants to talk about. And then sort of finally, kind of maybe now from not as much of an enterprise perspective, but from more of a individual employee perspective, a lot of people are interested in how do you find these kind of large enterprise organizations that have built up data science capabilities that feel like what a Google or Facebook would feel like, but aren't Google or Facebook? Right.
I'd say, there's a few signals that we use when we're looking for, like, is somebody a good fit or not? I think you mentioned the number of PhDs that an organization might have. That's a good signal. Like, are there people that have advanced degrees or have the ability to use languages like Python and R and Spark and Scala? I think that's sort of a basic filter, because a lot of times they don't call themselves data scientists. There might be some other name that they use in their industry.
So I think conversely, sometimes people call themselves data scientists when they use Excel.
Yes, exactly. So I think cutting through that is not the easiest thing in some situations, but I think there's clear signals there. I think, the teams that are typically doing the leading edge work or doing high performing work within an industry, they usually like to talk about it too. So I think, if I was trying to break into one of these organizations, I would definitely make sure to show up at conferences and local meetups and seminars that might revolve around different languages or tools that you like to use, because they're going to want to talk about that work. And we always encourage our customers to do that. It's like, if you're doing something interesting, that is your best recruiting tool, because no one's going to know about it other than your internal team. So you have to get out there and start talking about it. So I'd say that's probably the best recommendation I can make is, look at those.
Also an active GitHub account.
That's a good signal. As long as, well, sometimes that's a good signal, because a lot of times these large organizations aren't using, public GitHub repos or even a cloud-based GitHub repo. It's used behind their firewall. So sometimes that might give you a mixed signal, but it is a good indicator. If someone's very active on GitHub, that's usually a good sign that they've advanced their technique and are actually, producing work that's being used across the organization.
Yeah, absolutely. Well, thank you so much for taking the time to speak with us. Had a lot of interest and a lot of kind of very engaged questions. And of course, if you have more questions or more more interest, please be free to check out datascience.com, and you can learn more about their platform and their product. So I just want to thank our speaker, William, our audience, and I hope you guys really enjoyed this latest installment of Data Science in 30 Minutes. And if you're interested in learning more about data science, please do check out our website, www.thedataincubator.com, for more information about our free fellowship for PhDs and master students, and our online course offerings. And also, if you're interested in corporate training or hiring from our fellowship, you can also go to www.thedataincubator.com and learn more about that. All right. Thanks so much, everyone. Bye.
Thank you. Appreciate it.